Okay, students, in the last session we have drawn the graph of sine graph already we known to us. Now we will draw the graph of sine inverse. Graph of sine inverse of x. Better to write y is equal to sine inverse of x. Let me consider a plane like this. Y-axis means here y is equal to sine inverse of x and x-axis. We consider domain values on x and codomain means range values on y-axis. You see what is the domain here? Domain is from -1 to +1. Okay, -1 and +1. This will be 0. And what are the values? -90 to +90, like that it is proceeding. Okay, plus pi by 2, pi, 3 pi by 2, 2 pi, and on negative x-axis, negative y-axis, minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi. Now drawing the graph of this. Sine 0 value is 0, already known to us. According to the definition of inverse, we can write here sine inverse of 0 is equal to 0. Sine inverse of 0 is equal to 0 in the sense, when you substitute x is equal to 0, we are getting y is equal to 0. Means our point is 0, 0. What is sine 90 value? Sine pi by 2 is nothing but 1. This can be written as sine inverse of 1 is equal to pi by 2. Sine inverse of 1 is equal to pi by 2. According to this, when we substitute x is equal to 1, y is equal to pi by 2. X is equal to 1, y is equal to pi by 2 means point is 1 comma pi by 2. Where 1 comma pi by 2 will be 1 on the x-axis, pi by 2 on the y-axis. Here is the point. So, graph proceeds like this. Graph takes the path this is how the graph of y is equal to sine inverse of x is. Fine. Now, according to the definition, what we can write? According to the definition of inverse functions, we can write sine inverse of x is equal to x. This is like f circle g and g circle f concept. G was inverse of f. Here sine inverse is inverse of sine. Sine inverse of x is equal to x. If and only if x belongs to domain of sine inverse. What is domain of sine inverse? That is -1 to +1. So x belongs to the closed interval -1 to +1. And also sine inverse of sine theta is equal to theta only when x belongs to domain of sine here. What is the domain of sine? We have considered to make the given function sine invertible. We have considered from minus pi by 2 to plus pi by 2. Yes, here x belongs to the interval minus pi by 2 to plus pi by 2. According to the definition, we can write. Means whenever if we have y is equal to sine inverse of x, this can be written as x is equal to sine 1. Okay, if you observe the graph of sine and sine inverse, you see this is what? This is graph of sine x, and this is what? This is graph of y is equal to sine inverse of x. You observe both of them. Both are mirror images to each other on a line y is equal to x. Both are mirror images to each other. See, let me draw the graph of that y is equal to sine x first. Pi by 2, pi, 3 pi by 2, 2 pi. Here it is 0, minus pi by 2, minus pi, minus 3 pi by 2. somewhere here 1 minus 1. Draw the graph of this. Graph of this takes the form like this. If you draw the graph of y is equal to sine inverse of x on this, this is what? This is y is equal to sine x. We are drawing the graph of y is equal to sine inverse of x. Means for that, here will be plus 1 and minus 1, pi by 2, pi, 3 pi by 2 and 2 pi. This side minus pi by 2, minus pi, minus 3 pi by 2 and minus 2 pi. How the graph of this will be? Graph angle of the 3. Plus 1 will be somewhere here and minus 1 is somewhere here. Means 0. This point will be same for both and pi by 2 comma 1 will be there. Pi by 2 comma 1. Here is the point. Graph takes the form like this. This side when you substitute x is equal to minus pi by 2, that y value will be minus 1. Graph takes the form like this. And this is what y is equal to sin x is. This is what y is equal to sin x. If you observe the graphs of y is equal to sin x and y is equal to sine inverse of x, both are mirror images to each other on the line y is equal to x. This is y is equal to x line. How? Y is equal to x line will be a straight line because it is a linear function. When you take x is equal to 0, y is equal to 0, point 0 comma 0. When you take x is equal to 1, this is y is equal to 1, means a point 1 comma 1, 2 comma 2, minus 1 comma 1, minus 1 comma minus 1, minus 2 comma minus 2, like that it goes. So this is y is equal to x. Both are mirror images to each other. Fine. This is about a inverse of a sine function. Now we will take the next one, that is inverse of a cos function. Okay, coming to the inverse of a cosine function. Cos, if you take from r to r, real numbers to real numbers, this given function will not be 1, 1 and 2. This will be a function, but this will not be 1, 1 and 2. What to do? We restrict its codomain first to make the given function onto. How will you restrict? Range of trigonometric function cos is minus 1 to plus 1, but here codomain is given from given as all the real numbers. So what you do? We restrict it from minus 1 to plus 1. Hence the given function will be onto. Okay, onto we solved. That is fine. Now next thing I want to make the given function 1, 1. What to do? Let us understand with the graph first. Y is equal to cos x and this is x, 0, pi by 2, pi, 3 pi by 2, 2 pi, this side minus pi by 2, minus pi, minus 3 pi by 2 and minus 2 pi, 1, this is minus 1. What is cos 0 value? Cos 0 is 1. Means when we substitute x is equal to 0, we are getting 1. 0 comma 1 is the point. Here is 0 comma 1. What is cos 90? Cos 90 is 0. Point is 90 comma 0. 90 comma 0 point is here. Okay. Graph takes the form like this. This is about graph of y is equal to cos x. If you consider y is equal to cos x graph, where domain is all real numbers we have considered on the x axis. Now is this 1 1? No, it is not 1 1, because if you draw the horizontal line anywhere, it is intersecting at many points. So to make the given function 1 1, what we do? We restrict its domain. How to restrict? If you see from minus pi by 2 to plus pi by 2, as we seen in the sine theta, again it is intersecting at 2 points. This given function will not be 1 1 if you restrict from minus pi by 2 to plus pi by 2. What we do? We restrict from 0 to pi. You observe from 0 to pi, here is a line, and here it is. 0 to pi, in this interval, if you draw the horizontal line anywhere, how many times it is intersecting? It is intersecting at only 1 point. Means, if you restrict the domain from 0 to 5, the given function becomes a 1 1. Cos 0 to pi. This will be same, minus 1 to plus 1. In this interval, domain as 0 to pi and codomain as minus 1 to 1, the given function cos is bijective, means it is 1 1 and onto. As the given function is 1 1 and onto, there exists its inverse, that is written as a cos inverse. It maps from closed interval minus 1 to 1 to closed interval 0 to pi, where domain of cos inverse is closed interval minus 1 to plus 1 and codomain of cos inverse is 0 to pi. Codomain is nothing but here a range. Therefore, range of cos inverse of x is 0 to pi. Range is also called as a principal value branch. Principal value branch of y is equal to cos inverse of x is closed interval 0 to pi. Is this compulsory to restrict only the interval 0 to pi? No, it is not like that. 0 to pi you can consider, or you can consider it from minus pi to 0 also. If you consider from minus pi to 0, you see again the given function becomes a 1 1. You can consider it from minus 2 pi to minus pi. Any interval you can consider such that the given function is a 1 1. Means range of cos inverse of x can be minus 2 pi to minus pi, closed interval, minus pi to 0, 0 to pi, and also pi to 2 pi, 2 pi to 3 pi. Many intervals we can write, but this interval is there, 0 to pi, closed interval 0 to pi is called as a principal value branch. Principal value branch of cos inverse is closed interval 0 to pi. Now coming to the graph of y is equal to cos inverse of x. Y is equal to cos inverse of x graph. On x-axis we take domain values. All the values from minus 1 to plus 1, means somewhere here minus 1, here plus 1, and its codomain values, range values, or we will consider on y-axis, that is pi by 2, pi, 3 pi by 2, 2 pi, here it is minus pi by 2, minus pi, minus 3 pi by 2, and minus 2 pi. Very simple to draw the graph. We will see. If you consider cos 0 value, how much is cos 0 value? Cos 0 is equal to 1. This can be written as cos inverse of 1 is equal to 0. Means here the point is 1 comma z. When you substitute x is equal to 1, it is giving us 0. In the sense, point is 1 comma 0. Where will be 1 comma 0? On x-axis 1, y-axis value 0. This is the point. Next, coming to another one point we can consider. What about the cos 90 value? Cos pi by 2 is 0. This can be written as cos inverse of 0 is equal to pi by 2. Means what is the point here? When you substitute x is equal to 0, it is giving us pi by 2. So point is 0 comma pi by 2. 0 comma pi by 2 will be on the y-axis. This is the pointer. So graph takes the form like this. This is how the graph of y is equal to cos inverse of x is. According to the definition, what we will write? According to the definition of inverse of functions, what you said? In that case, if f is a function maps from a to b, then there exists a function g. It maps from b to a, then we will be having f circle g is an identity function. F circle g of y is equal to y will be there, and z circle f of x is equal to x will be there. This one we have written. Okay, fine. In the same case here, cos and cos inverse you observe. Cos, it is mapping from 0 to pi to minus 1 to 1, and cos inverse minus 1 to 1 to 0 to pi. So we will write the formula here. Cos inverse of x is equal to x if and only if x belongs to the interval domain of cos inverse, that is closed interval minus 1 to plus 1. And again, cos inverse of cos theta is equal to theta if and only if theta belongs to the closed interval, that is domain of cos theta, that is 0 to pi. Fine. This is about the inverse of cosine function. About the problems I will solve later. Otherwise, let me see 1 or 2 examples here. What about the value of cos inverse of 1 by root 2? Cos inverse of 1 by root 2 value is what? It is very simple. What you do, you remember the table what you have studied in SSLC trigonometry. There we have studied 0 degree, 30 degree, 45 degree, all those. Cos inverse of 1 by root 2 is there. Cos inverse of 1 by root 2 in the sense, just to remember, cos of which angle gives you 1 by root 2? Cos of which angle gives you 1 by root 2? That is 45 degree. 45 degree in radians pi by 4. So cos inverse of 1 by root 2 is pi by 4. Very simple way of writing. Or else we can solve it like, let cos inverse of 1 by root 2 is equal to y. This is nothing but 1 by root 2 is equal to cos y. 1 by root 2 in terms of cos we have to write. 1 by root 2 in terms of cos is nothing but cos 45 degree. Cos pi by 4. Cos pi by 4 is equal to cos y I have. Cos get cancel. Y is equal to pi by 4. Y is nothing but cos inverse of 1 by root 2, which is equal to pi by 4. If cos inverse of, tan inverse of, whatever, all such trigonometric functions, inverse of positive values are there, directly we can write like this. Suppose inverse of trigonometric functions and negative values is there, in the sense it is better not to follow the method whatever we have followed here directly. We will write it wrongly. We will solve those problems by using properties of inverse trigonometric functions that we will explain in the next sessions. Okay, fine. This is how we can take. After explaining the inverse of properties of inverse trigonometric functions, we can write all the values. Now only with the positive values. We can try all positive values with for sine inverse and cos inverse. Thank you.